Okay, thank you very much. My name is Dusak Fialo. Today we're going to see topology optimization on stool model. Let me go through the process one by one. Now we are in the Creo parametric optimization area. Now simply to bring or import a new model, we go to file, and then after open, then we have, actually this one is the part that I modeled before. Now let me click this one, then after open. Now this one is our model. We do have three parts. First one is this big cylinder extrude. The second one is here. We do have additional part that is created up on the top of the model. The third body is here. I do have three small cylindrical shapes that are used as the stool legs. Now this is our model. If we're going to perform the topology optimization on this original design, we go to applications. From application we come to the generative design. Actually, generative design and the topology optimization is the same. Sometimes when we say generative design, it is simply when we have multiple amounts of concept for the original design, and the topology optimization is mainly for performing single the results of the topology optimization is single optimized model. Now in our case, let me click this one. Okay, now actually here this one is the one that I performed before. Now let me cancel this one and go through these steps one by one. Now let I erase this selected body, remove this one. Here also remove this one. Okay, we go to the steps one by one. Okay, select this one. One is selected. The second one is true. I'm sorry, it's not showing me. Then collect this one. Okay, simply click this one. Okay, that one is selected, assigned. Now let me go to the second step. That one is providing the boundary condition and the load. The boundary condition is sometimes we say that one constraints. Now the constraints that we have in our case is the fixed one. Let me select the fixed constraint. That fixed constraint is this leg is fixed to the ground, and fixing that one to the ground, and then after applying load or pressure upon the top of the surface, okay, surface of the stool. Now this one's the fixed boundary condition. Then when we come to the load, for load we do have force, moment, pressure, and centrifugal accelerations there. Now for us, let me apply pressure. That pressure is applied upon this face. Okay, select this face. Okay, this is the distribution of the pressure. Now select the unit. The unit is, let me say, in megapascal. Then let me say 125 megapascal. Okay, then take that one, take the pressure, the load that is applied upon the system. Now the two steps are finished. If there is some errors in this procedure, it shows with red or some yellow icons like this one. But in our case, all the design spaces and the structure boundary condition and laws are properly applied, for that case all of the steps are right. Now click this one, then on the screen we see this this star-like icon, so click that one. That one is for providing the material and also the amounts of, we provide the amounts of the mass that we remove from the model. Now this pop-up icon will come, then go to add material, then cancel this one. We do have those types of materials. Now in our case we're going to deal with the wood. So woods, from woods we do have bamboo, cork, hardwood, hardwood beech. Let me select the first one. Now let me come to the hardwood. Okay, so here in the selection, one item is selected, then select that one. 50% of this starting geometry is retained. Okay, so hardwood is applied on for the material. They take this change. Now on the optimize we have to click this one. Okay, now you see here one process is in session. Now it is performing the topology optimization on this stool. Now when you look, you see the geometry. It is gradually removing materials from the design space. Now it is finished. Now the maximum second that we used for this analysis is 0. It is 23 second. Now the optimization, the topology optimization is finished. Okay, for simply displaying the simulation result, come here. Let we go to this one. Is the when we remove 50 when we retain 50% of the mass. Now let me add additional analysis material removal. Add material from material, the same thing, the same material we applied, but here let me make this one 30. Now when we say 30, it is the amount that is retained. Let me perform the optimization. Okay, now the optimization is started. Now it is optimizing. Now this one is 30% material removal, no, 70% material removal. Then let me add additional more. Let me, for this case, let me say 15%. Add material, the same material. Okay, then okay. Now run the optimization. Now this one's the 15% material retained from this point up to this stage. Okay, thank you very much for this session.